So a little bit of an overview of what we're going to talk in the next half an hour. We're going to give an overview of the architecture, the code structure, what's the development environment, how to deploy it, what's the development workflow, and how to contribute to µONOS. So just as a refresher, Ray probably talked about this, but the idea is that we have µONOS, which is the next generation architecture of ONOS, to provide a comprehensive platforms for operation, among which is configuration, control, monitoring, verification, diagnostics, have a one-stop shop really to manage everything in your network from basically a zero-touch perspective. We also want to provide a first-class support for the 5G RAN edge, and you could ask why the M. It's because it's microserviced gRPC interfaces with next-generation SDN APIs such as GNMI, GNOI, MP4 runtime, all deployed in a cloud-native Kubernetes aimed at the edge cloud. We have a set of repositories under GitHub that reflect the component architecture. All of these are built and packaged independently, meaning that you can make a change, and Jordan's going to show this later, to one of them and keep the rest as you have. Rebuild that Docker image and redeploy it in a very Kubernetes-like fashion. At the moment, we have ONOS config, which is what we started with, ONOS topology, ONOS control, ONOS GUI, ONOS CLI, ONOS test. Clearly, this is not at the same level. ONOS config is much further along than ONOS control, for example. That's what we decided to start with. There's going to be more refactoring. We're going to take out some tools. We're going to add some more repositories depending on the apps. For example, we added a ONOS zero-touch provisioning app. That is the one that was shown in the demo. So that's kind of how it goes. Every microservices gets his own GitHub repo. And all of them are hosted under GitHub ONOS project, and you can go there. All the code is open source. It's not released, but we welcome contributions to it. Again, just an overview of the ones we have at the moment. GUI, CTP, test, topo, config, CLI, control. Simulators, that contains a set of device simulators for GNMI that we use for development, RAN, registry, and all of those under ONOS project. The whole idea with this set of different repositories, but we also want to keep them very consistent. The idea is that the tools, the operations, the processes that we're going to show from now on apply to all of these repos, meaning that you learn the workflow, the tools, the setup, how to deploy it once, and you can make changes and contribute and use and modify, depending on your need, all the microservices. So you might ask, what are all those microservices and how do they work together? And I'm going to allow Jordan to speak about this.
Yeah, so if anybody came by our demo booth, it's now gone, but this is one of the slides that we showed. So this is basically the overall architecture. And you can sort of see how the GitHub repositories that Andrea showed maps onto the services. So for example, we have a topo GitHub repository. Well, that, when compiled, is the topo service. We have a config GitHub repository, that's the config service. This key value store is atomics, as we've been discussing, which I'll talk about more a little bit. And then applications run on on top of all these core services. And generally, all the communication between these services is done over some form of gRPC. The reason being, the original version of ONOS had some issues with schema evolution. We ran into problems when trying to implement ISSU, and so by using gRPC for most of our communication wherever possible, we hope to sort of mitigate those issues and also take advantage of the efficiency of streaming and just all the work that the gRPC team has done. So if we look at the Kubernetes UI, this is another thing that was shown in our demo out there. So basically, this is what those services look like when deployed on Kubernetes. So this is showing, for example, the topo service, a set of pods running inside Kubernetes. That amounts to the topo service, a set of pods running for config, which does the GNMI, a GUI pod, which controls the user interface for config, a CLI pod, which allows you to use the CLI, which I will do a demo of. And then all of these, when deployed inside Kubernetes, are exposed via services. So services in Kubernetes are sort of host names through which you can access specific pods. And so each of the microservices that run inside Kubernetes, I'll also do a demonstration of this, are exposed via a service, which means they can be reached from applications or any other subsystem that wants to use a specific microservice. And you notice that there are a couple components here at the bottom that we haven't discussed, which are Raft and Raft1. These are services that are exposed for the database layer. So as I was mentioning earlier, Atomics is it's essentially a key value store. It's sort of like a data structure server, sort of like Redis, except it's distributed, uses consensus, and so it's really suitable for coordinating the cluster, for doing mastership election, for storing configuration changes and things like that in the case of our config service. And so there are two components that you'll see deployed inside of the µONOS cluster that you probably want to understand. So they're basically, Atomics has been re-architected in a cloud-native architecture like the rest of µONOS. And so you'll see two components. One component is the Atomics controller. This is essentially a Kubernetes operator that's tightly integrated with Kubernetes, uses custom resources to manage the database. And then you'll see Atomics nodes, which were those Raft nodes. And then each of these services that run inside the µONOS cluster use the Atomics Go client library, which is essentially just a library of data structures and other primitives that we use for persistence and cluster coordination. Andrea.
So all of this, most of the components that you have seen have been written in Go. We chose Go because it has significant momentum in the ecosystem. It supports natively gRPC, which again, GNMI, P4 runtime, GNOI, these APIs that we think that are the future of SDN are gRPC based. So with this native support for gRPC, Go was a natural choice. It was also a natural choice because it was supporting streaming APIs with channels. Those were very helpful when dealing, for example, with events and how the system would proliferate the status of things inside itself. gRPC is also very useful because, for example, the admin CLI uses a service that we expose to do things that GNMI was not allowing us to do, such as rollback. It does not have Java Virtual Machine, and it does have garbage collection, and garbage collection is something that everybody who worked in production with Java is well known for having to tweak. And so the garbage collection in Go is less prone to memory leaks, is faster and safer for code development. Sometimes it does happen that Go code has the need for stop the world pauses, but they do not have the impact in real time requirements because there's only like 500 microseconds stop the world pauses that they do not really affect the real-time sensitive elements. And if you really want to need for not having these stop the world pauses in some pieces of the code, you could use the foreign function interface from Go to write your code in C, C++ to handle those specific, definitely time-sensitive elements that you don't want to handle with Go. So we decided to go with a standard Go project structure that is Golang standards projects layout, which is applied, as I was said before, to all those repos. So you'll find the command package, the PKG package, the docs package. And so it's a standard layout, which you can understand once on all these repos, and it's a well-known element in the Golang community, and everybody uses it. And we decided to go for it in all of our repos. We also do dependency management through Go module. We tried deps for some time, but then since the whole Go community is actually now pursuing, since Go 1.11, the Go modules subsystem, we actually decided to use that. So you turn it on with the first go11 module equals on, and that uses go sum and go mod to bring in the dependencies that are needed in your code. Then we take this Go code that was written for ONOS config, ONOS topo, or whatever of those services, and we package it in a Docker container. That Docker container is then tagged and published under Docker Hub, under ONOS project. And if you just want to start with it and try the deployment, you don't really need to build anything. You just download every image from Docker Hub, you spin it up, and you're there. If you want to change some code and you want to try out your own code that you made, every repo has a target which is called make images that builds the images for Docker based on the code that you have changed in your own local copy of the project. So again, make images is a target that we made the point of putting in all our repos. So it's kind of like a no-brainer. Oh, I changed some code in topo, make images. I changed some code in ONOS config, make images. Doesn't change. Then, as Jordan said, we deploy on Kubernetes, and we do it in one of two ways. For a production deployment, obviously, Helm charts. Those are the go-to tool that everybody is using in the industry that enables you to deploy Docker containers and other elements on any type of Kubernetes deployment. We also have wrote the ONIT test tools, which Jordan will go over later, for that deploys ONOS config with particular set of images and particular set of debugging tools that enable you to look into the code and inspect it in a far higher, in a far deeper manner than just the pure Helm charts do. Then we can run Kubernetes on bare metal. The demo show floor, we were showcasing just plain Kubernetes running on our server. Or for our own development, we chose Kind, which is Kubernetes in Docker, which is a very lightweight implementation of a Kubernetes cluster in your own Docker daemon on your machine. It can run on Linux, it can run on Mac. It comes from the SIG group of the Kind SIG group in Kubernetes. It's very lightweight, and you just have to have installed Docker to run it. So in short, what happens is that you take the Docker, you take Golang, you package it in a Docker container, and you deploy it in Kubernetes. That's what the industry is going for in many, 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 many different projects. And we decided that the next architecture of µONOS had to do it like this. So then, for ONIT overview, I'll let Jordan continue.
Yeah, so sort of coming from Java and coming from that monolithic architecture, a lot of our developers were just getting introduced to Kubernetes for the first time. And I had been doing it for a little longer, and I think I started last year. And just having experienced that, I realized how intimidating it can be learning all the new abstractions and figuring out how they map onto real-world concepts and things like that. And so we wanted to build a tool to make it easier for ONOS developers to get introduced and started on Kubernetes, and also be able to start working on the test infrastructure for µONOS. And so we created this tool called ONIT. It's basically well, I'll do a demo of it, hopefully if these videos work. I'm not sure if they're going to work. I can't promise. But so it's a CLI tool, so it helps you set up a cluster that can be debugged inside Kubernetes. It can run on Kind or on bare metal. We're actually using this for the demo that we just took down. It supports running integration tests, running benchmarks, which I'll do a demo of the testing, and supports remote debugging. So some people have asked, how do you debug? How do you debug inside of Kubernetes? Well, this is the answer to it. And then it helps you, provides functionality for deploying applications. And so I'm just going to get into some of the demos if these videos work. All right, so yeah, so there's some documentation online, and we'll show a little workflow that people can look up after this talk. But just to demonstrate the ONIT tool, that move thing is in the way, but maybe I'll make it a little smaller. So this is showing setting up a cluster. So essentially, ONIT, as I said, is a command line tool. I entered ONIT create cluster, and this does. That's a video, yeah. There we go. So that's as good as it gets. Yeah, so this basically sets up all the prerequisites for deploying the cluster. So for example, there's an atomics controller that an administrator would normally have to set up, role-based authentication control, and it does this all in its own namespace. You can see it's bootstrapping the ONOS topo service, the config service, and then after this, you'll see it deploy the CLI service, the GUI service, etc. And this sets up the everything that you need to run tests, etc. And so you can see I looked at the namespaces, so it created a test namespace and deployed all this stuff in that namespace, and deployed all the pods that I showed on the Kubernetes UI a moment ago. Yeah, so I mean the ONIT help shows basically all the functionality that comes with it. So it supports things like adding device simulators, deploying mininet network, adding applications. It has a lot of debug features, like there's this debug command that connects a remote debugger, has support for downloading logs and things like this. Now these are all things that can be done with normal Kubernetes commands, but those commands can be pretty long and complex, and so this just greatly simplifies the experience when working with Kubernetes. So this is sort of a little demo of how integration tests work. So you can run ONIT get test to list the integration tests that we have, and we'll continue to add these over time. And the way that integration tests are run, you can see it says starting test job. So this actually allows us to run tests inside Kubernetes like an application would be running. So it deploys, so it builds an image of our test suite, deploys that as a job inside Kubernetes and runs the tests, gets the exit code and returns it just like as if you were running the test locally. You can access the CLI. So one of the things that was running inside of the ONIT cluster was a CLI pod, and you can use ONIT ONO CLI to either execute a command directly or open a session into that container. And this is a container that's running inside the Kubernetes cluster. It gives you access to the CLI for all of the services. So what I'm doing here is adding a device to the topo service, and this will be something that I'm making a change to, and I'm going to show you how to make a change to the add or to the CLI, how to test that change. Yeah, so what if I want to make a change to that? So first, there will be a little workflow chart after this that shows this entire process in a chart. But first, check out a new branch. So what I'm going to do for this demo is I'm adding a type flag to the get devices command. So I added a device with the type stratum, and I'm just adding a filter as a demonstration how you can change the get devices command, test it, and contribute it back to µONOS. So this is just a little code change to add a device type filter. So once I make my change, my next step is that I want to test it, obviously. So as Andrea mentioned, each of the subsystems has a make images command, and this is how you build the Docker image. And so yeah, so this building the Docker image, well, so you notice that I did this in the CLI repository. So there's sort of, in the case of the CLI, there's a pattern wherein I was modifying the topo CLI, right? I wanted to change the get devices command. So each subsystem has sort of a subset of the commands in the CLI, and the code for those commands is in each repository. So the ONOS topo commands are in the topo repository, the ONOS config commands are in the config repository, and this ONOS CLI project that I'm building aggregates all of those. So I can make a change to the ONOS topo CLI in the topo repository, and then come back to ONOS CLI, build it all, and this is going to build the CLI container, which I'll deploy in Kubernetes. And the other detail is that I'm running this on a kind cluster, And so the next step after building the image is that I have to load my new image into the kind cluster. Now this will differ based on how you're doing your local deployment. Minikube allows you to sort of link your Docker daemon to the one that's running inside the VM. So each, I'm not sure how microK8s does it, but each of these local Kubernetes clusters has its own sort of way of getting images into the cluster. All right, so and then once I've built the image and gotten it in the cluster, in order to redeploy it, so ONIT supports an ONIT set image command, and so basically what this is doing is telling ONIT to redeploy the ONOS CLI with a new image. And so once that command is run, you'll see when I run kubectl get pods, you see that it terminated the old CLI, restarted the new CLI. And then once that's been done, I can use the new CLI to test out my change. So I just did ONIT ONOS CLI to get into the CLI pod again. You notice that the type flag that I added is there now. And I should be able to run that command. Foo is not a type, so there are no devices. But if I change that to stratum, then I have successfully tested my change. And so then what do I do after that? Well, then since I've tested my change successfully, time to commit it. So the fork commit pull request pattern will be shown in a graphic, and there are documents in some of the repositories for it. But commit, give it a good message, push it to my fork, and then the final step. Now I'm going to open a pull request. So, I mean, whatever subsystem you want to make your change in, just go to the repository. You'll see a compare and pull request button. Give it a title, give it some reviewers. I'm going to assign Thomas and Andrea to review this. Good luck. And yeah, give it a good message. And then a little bit about the pull request process. So generally, all of the pull requests require one approving review. It should hopefully make suggestions about who can review it if you're not sure. Then you can assign, we have labels for bugs. If it's a bug, you can label it as a bug. Or if it's an enhancement, you can label it as an enhancement. And then the other component is that when a pull request is opened, you will see that it also has some checks. So this is the CI. And inside, so CI is done on Travis, as was mentioned. And this will run the tests, et cetera, and the pull request won't be able to be merged until those tests are successful. And those are the sort of prerequisites for contributing back to µONOS. So I think that is it. Yep. I'll give it back to Andrea.
Thanks, Jordan.
Once we find this.
There. Oh. Thanks. So what Jordan showed mostly is also documented. Right now it's under ONOS config. Might be moved under an ONOS docs if we decided to have that repo by itself. Just look for that picture. The idea is that the whole document explains you how to fork the project with exact commands, download the code, create a local development, just then code it, build it, test it, as Jordan showed, then submit a pull request. What then becomes of your pull request depends on your reviewer and your interaction with the community. You cannot just come give us your code and expect us to merge it. It has to adhere to some standard. It goes to the linters, the check styles. It also goes to the reviews. As Jordan showed, we can add reviewers. And when you add reviewers, those reviewers get an email, and we took a look at the code and say, okay, this is good. You might do this better. We like this approach. We always welcome contribution. Then we work with you until we get your PR merged. And then you can see your code in action by just getting the latest image from Docker Hub. So a little bit of background. Why did we pick GitHub? Because we use it as an all-in-one integrated tool for code, issues, comments, documentation, PRs, and CI/CD pipeline. The idea is that we wanted to avoid multiplication of tools and learning curves for different tools. We want to explore an all-in-one integration. It's a one-stop shop, so you go to the GitHub repo, you find everything in there from the documentation, which is versioned, stays with the code, and you can go back in time as soon as you go back in time in the code, you go back in time with the documentation. And it has also a very well integrated CI/CD with Travis on the PRs. So we picked Travis because it's a simple, well-known, ubiquitous CI/CD tool. What that does, it basically builds the Docker images on top of your submitted changes. It deploys a kind cluster on a Docker demo that is running there with your new images, launches the integration tests, and if they pass, it goes and checks the license, goes and checks the check styles and some set of Go linters. In particular, we use the Golang CLI lint tool, which does lint, vet. It basically checks the quality of your code as much as it can do from a non-functionality perspective. It checks that all the variables are used, that you're not losing anything in terms of like unused variables, or there is some piece of code that is not used that we don't know why it's there. So if all of these pass, usually the reviewer steps in and takes a look at it from a functionality perspective. So last but not least, since it's perfect, how to get involved. Join the µONOS channel on Slack from the ONOS project. We have TST meetings bi-weekly at Wednesday at 9 p.m. where we usually give a project update for what we did in the past few weeks. Obviously, fork the project and send a pull request. We just show you how it's done. So we welcome contribution. And there is always the ONOS Dev at ONOS project mailing list. And just a few follow-up links, which don't really show here, but that's okay. On the online thing, you can find the µONOS repositories here and the Atomics repositories where you can contribute to it. So that was that. Thanks for listening to our talk. Do we have time for questions, Ray? What about 1 or 2 questions for me or Jordan?
Anyone have any questions? Okay.
Let's see, who is it?
And so you're saying that you want to use a GitHub capability for issue tracking, but currently you have several repositories for µONOS project, and how you solve the problem that if issue connected to 2 or more repos, how it should be solved, how it should be managed?
Yeah. So there's one way, which is one simple way, which is there's probably one repo where the PR is mostly relevant to. Let's say you are changing, you're putting in a new set of files in ONOS config, and then you want also to add a CLI command. So you found that this is what you need to do because you're adding a new functionality in ONOS config, and then there's a CLI command to it. So in my opinion, the simplest way to do it is you open the PR under ONOS config for the set of changes that you want in ONOS config and the issue under ONOS config. And you also open another issue for the CLI command under ONOS CLI, and you link them between the two via just basically the PR link that shows up on GitHub. At least that's an easy way to do it.
Yeah, so
You have to serialize that because your CLI, in your use case, the CLI may depend on the config being there.
Yes.
It might already have to be committed and merged before you can run an automation test against it.
Yep. Yeah.
Yes.
So we can reference. So yeah, we can reference other repositories in GitHub, but there is sort of an issue where multiple issues that depend on each other. There's like an ordering issue as far as when they're merged and when CI could potentially run and break because not all of the pull requests have been merged, and it's one of the issues with separating the repositories rather than using monorepo. But that just comes with the territory, I think.
As well, we broke it up into multiple repos, and usually, two will go in, one may depend on the other, and
Yep.
Jenkins will fail the one outright because the dependencies.
Exactly, yeah.
You tend to focus on the other, get it right, and then the other one just follows along.
Sure.
So usually you just pick one and kind of focus on getting the one right.
Yeah, makes sense.
Yeah, I think this is a really important issue, you know, that especially when you have breaking changes, where if you merge, where, you know, A depends on B, or mutually dependent changes, A depends on B, B depends on A, so they really have to be merged in consistently, or else you'll have a window where CI just doesn't pass and nothing can be merged, and you're sort of out of luck. So my question is, you know, how do you handle those mutual dependencies, and also how do you handle versioning when this CLI requires this version, you know, this ONOS CLI requires this version of ONOS config, or vice versa?
Do we handle versioning? I guess so. I think an answer to that is, when do you really? So if it's at the pull request time, I think that's a manual versioning. How do you handle versioning in a deployment? That depends on what you want to deploy. For example, in a real deployment, you pick a Helm chart and you define the set of images that you want to deploy at a certain point in time. So you can do latest for the CLI, but not the latest version tagged 1.0 for config in a deployment. In a PR scenario, that's probably, at the moment at least, a manual step process.
If I can add, so it's a straight dependency.
The dependency graph is a DAG, so no cycles. There's no cycles in the dependency graph. Which means, you know, we cannot have A depend on B and B depend on A. And it's actually the case even in a monorepo today with ONOS because of the build modules. Now there is still the issue of one change going in before the rest of the world is ready for it. So that still exists, but you're not going to have a deadlock, so to speak, in terms of dependencies. And also with respect to the issues, to answer Nikolai's question, to add to the answer here, we do track issues that are specific to each repo, that's correct. And like Jordan said, you have to kind of figure out where the issue is more related to and track it there. But generally, the idea is to move towards the world where we release each of those modules individually and independently of each other and use semantic versioning so that they exist as independent entities, which is unlike what we do today with ONOS. Because, for example, we have 180 different applications and we version them regardless of whether or not there was any change or even any significant change in them. So, you know, we just released 2.2 and there's most likely more than half of those modules, the apps or extensions that have not changed at all since like 3 releases ago. And yet we still go version them differently, and that's not necessary anymore in this new world, which is I think, much easier to think of.
It is nice though, because you know with the release of ONOS, everything works together, right?
There's downsides to everything, yes.
Yeah, the other idea is that you could look also at the Helm charts to say, this works with that, and since the Helm charts are versioned with the code, at certain point you could go in the branch of the code and say, okay, at this point this Helm chart worked for deploying this set of images for ONOS for µONOS. So it was ONOS config 1.0, it was ONOS control 0.3, it was ONOS CLI 1.2, and that Helm chart specifies what could be considered an overall system release. That's
a good point.
Sure.
Yeah, sorry, just wanted, so because now you have multiple repositories one for each component, so if someone wants to write a component that says and is an adapter or something like that, how would be the model in the future for introducing or not introducing new components in the system and aggregating those?
Want to take that?
I think that's a Thomas question.
I mean, I can give my opinion and Thomas can. My idea is that there are 2 ways. So we want to keep this /ONOS project repo very lean, like very minimal. We will put there just the very basics of the system. We're not going to put everything in there. You're not going to see like the current ONOS, which has 180 apps in this repo. You're not going to see 180 repos in here. You're going to see the bare minimum, the most significant components in there, but not the whole thing. If you develop an app, that means you could do one of 2 things. You could upload it on Docker Hub, just the Docker image, and you could reference a Helm chart somewhere in your GitHub saying an augmented version of µONOS with my app deploy this Helm chart. The other way we also encourage is that we started an app registry. It was not really shown before. but what is this? Go away. It was not really shown before. I didn't talk about it, but there is an app registry under the ONOS project where we encourage you to put a JSON file that describes your app and describes where to find it and which version of ONOS can work with. It does it for the old version of ONOS, but also the newer version of ONOS. The idea is to extend it and include your app there, meaning that there is an official location from ONF where you can say to everybody that you have an app, and then people can go there, download it, and see your Helm charts and see how to deploy it. Does that answer your question? Perfect.